Let's check out this example together. We have a helium balloon that is floating at a height of 1.7 kilometers above the ground. And above the ground at that height, the air density is a little bit less than what it is on the level of the ground. And its density is equal to 1.1 kilograms per meters cube. Now, if the balloon has a volume of 3,300 meters cube of helium, and the density of helium is really small, 0.179 kilograms per meters cube, and we need to find the load, which we will call W sub L, at which the balloon can carry and stay afloat at that height. Okay, so we need to use Archimedes principle to be able to solve this problem, with the fact that there are equilibrium of forces, or there is equilibrium of forces for this one. Okay, we know that the buoyant force FB is going to be up. Okay, other forces that are acting on the balloon itself is the weight of the balloon, assuming that this white frame is really weightless. Okay, that's kind of like an approximation, that's okay. So the weight of the helium, so I'm going to say W sub He for helium. Okay, and this is the weight of L is going down, the load. All right, so at equilibrium, the buoyant force must equal to the weight of the helium plus the load, or the load that the balloon is carrying. Okay, we know that the buoyant force is equal to the weight of the displaced fluid. The weight of the displaced fluid. The weight is equal mass times gravity, and mass is equal to the density times the volume. So the displaced fluid is air. Basically, the displaced fluid is air, because when the balloon exists in the atmospheric air, it's going to displace air. Okay, so it's going to be the density of air times the volume of air times the gravity, and that would be equal the weight of the helium. Okay, now the weight of the helium will be what? Mass of the helium times the gravity, but we don't have the mass of the helium, we have the volume of the helium, and we have the density, so we have to use also the density of helium here times the volume of helium times G, and that's what we're looking for, the load that the balloon can carry. Okay, so now let's just plug in some numbers. The density of air at this height is equal to 1.1 kilograms per meters cube, times the volume of displaced air is the same volume as the helium, which is 3,300 meters cube, and gravity is 9.8. That must be equal to the density of helium, and the density of helium is 0.179, much smaller than air, 0.179, times the volume, which is the same, 3,300, times 9.8 for gravity, plus WL. As you can see, the only unknown in this problem, in this equation, is WL. So this is one equation with one unknown, and to find WL we can use some calculation to find that this number here is equal to 35,574. That must be equal to this whole number. If we calculate that, that would be 5,788.8 plus WL, then take this number to the other side, so it becomes 35,574 minus 5,788.8, and that should be equal to WL. The weight of the load should be 29,785 0.2 Newton. And that's it. Thank you.